So we're going to look at some examples here. And again, if you guys like have some, vague recollection of like how you would solve these, and you want to like ask me about them, let me know. I'm going to show you kind of like the way I kind of think about these things, and then we'll proceed from there. Okay. So, okay, let's just start with a problem here. So let's say we want to factor 3x squared plus 20x minus 7. Okay. Okay. So, first of all, that word factor means to kind of like break up into a product of two or more things, right? So when we factor something, we kind of take a quantity that we already have. So we have this. We want to break it up into a product of two or more things. When it comes to factoring, right, we have a lot of tools to help us factor. For example, we have something called the greatest common factor, right? Is there a greatest common factor for this particular problem? Is there a GCF that we could factor out here? Right, Miranda, there isn't one, right? There's nothing that we can divide each one of these three things by, right? 3 and 20, there's no number that divides both 3 and 20. And then you throw in the 7, and there's no single number that divides all three of those numbers. Likewise, there's also, not every term has an x, right? This has an x, this has an x, this one does not have an x, so again, we're kind of stuck. We can't use GCF here. So the other thing that we can go to is to factor as a quadratic. It's in the form, ax squared plus bx plus c, right? That idea. And so to factor this, right? Does anyone remember how do you factor something like this? What was the strategy? What are the strategies you guys have used in the past? Miranda, remember?
Find factors of 3 and then -7.
Okay, so find factors. So you want to multiply the 3 and the -7 kind of thing, or you said factors of them?
Yeah.
Okay, like numbers that multiply to make 3 or multiply to make -7, that kind of thing. Okay, yeah. So you're on the right track there. That's a way to go. What I'm going to show you, let me just show you guys a technique here to do this. So if you take the lead number here, 3, and multiply it to that -7, we're going to get a number, and we get 21, right? Or -21, right? All right. -21. And then we also still have this middle term here, 20, that we haven't talked about yet. And so we want to come up with two numbers that multiply to -21, but that add to 20. So we need two numbers that multiply to make -21, but that add to make 20. So, any ideas here about what those numbers might be? Two numbers that multiply to make, yep, sorry. We can just go ahead, sorry. -21 and 1? Like that? Okay, so those do multiply to make -21. -21 plus +1 is going to give us -20. We need +20. So you're really close to this point. 21 and -1. There you go. That's right. Okay, and that gives us that +20 that we wanted. Okay. So again, and this might be a little bit weird here, but what we're going to do is we're now going to take this, and we're going to take that middle term, and we're going to break it up into these two numbers here. So instead of 20x, we're going to rewrite it as 21x minus 1x minus 7, like that. Okay. So you'll see these two things are equivalent, right? If I were to combine like terms right here, if I did 21 minus 1, I would get back to the 20 there. I would be simplified. So why did I break it up? Why did I make it unsimplified here, right? Why did I do that? Well, because now we can do something called factoring by grouping. If you group the first two terms, and you group those second two terms there, those first two terms now have a GCF. What can we factor in common out from those first two terms? A 3 and? A 10? Not a 10. Nope.
7.
Oh, a 7, you're saying? It will, when we factor a 3 out, there will be a 7 left. But again, just looking at these first two terms, we can take a 3 out, and what else? An x. They both have at least an x, right? And so the most we can take out there is an x. So we'll take out a 3x, and we're left with x plus 7, right? 3x squared, if you take out 3x, you're left with just an x. 21, if you take out a 3, you're left with 7, and then you take out the x, so it's just a 7. And then what can we take out from these two terms right here? Any ideas? Well, they're both negative, so let's take a negative 1 out. That would leave behind a positive x and a positive 7. And then look at that. Both of those have an x plus 7 left behind there, right? And so we can factor out an x plus 7. Okay. And if I take out that x plus 7, what's going to be left from here? If I take out the x plus 7, what's left still from this piece? I have 3x times x plus 7. If we take out the x plus 7, what's left? 3x, yeah. Okay. And if I take out the x plus 7 from here, what's left? Minus 1. And there it is, factored. Okay, that's the answer. Now that's one way to do it. Does anyone remember doing it this way in the past? Yep, okay. Mary, do you remember doing it this way? Okay. Alright, there's another method you can use here called like the X or whatever, the magic X I think or something. Do you guys hear about the magic X? You guys Yeah, the X method, yeah. Have you done it that way?
Yeah.
Okay, so another way to do this is you draw an X. Okay, and in the top part of the X, you're going to do the 3 times the negative 7, right? Is that ringing a bell? Yes? Yeah. Negative 21 up here. And then in the bottom part of the X, you're going to put the 20, right? And so we're going to use your numbers again because we know that's right? So we're going to have a 21 here and a negative 1 here, right? So this is an alternative way to do it. Similar idea. Again, the idea is you want to multiply to this top number in the X, and you want to add to the bottom number in the X there. Okay. So is this ringing a bell for some of you guys, I hope? Maybe yes? Okay. Okay, good. Good. Yeah, I know Mr. Welch likes to teach it this way, so, yeah. Okay. And so, we got one more step here to do with the magic X, right? Once we come up with these two numbers, what do we still have to do? You guys remember? We have to divide them by 3. We divide by that A value there. Divide by 3. Okay. 21 divides evenly by 3, so that's just going to be a positive 7, right? And so this thing factors to be x plus 7. That's one of the factors. You get the 7, so it's going to be x plus 7. This one, that negative 1/3, does not simplify. So what we're going to do is that 3 in the denominator, it will be in front of an x, and then you have the minus 1. So the 3 kind of will slide out in front of the x like this, and then minus 1. And there it is, using the magic x. Okay, that's another way to do it. Again, it's just like a little technique to help you remember what to do exactly, or help, kind of help organize the thinking and stuff. Okay. Does anyone remember a different way of doing these than the magic x here? Anyone do it a different way than that? Okay, so this is all something we're familiar with then, hopefully, relatively. We just need some more practice, that's all. So let's try another one. Okay. Let's factor 5x squared minus 17x plus 6. So shall I just use the magic x again? Let's do that. Okay. So what number goes in the top of the x here? 30, right? 5 times 6, 30. And what number goes in the bottom? What's that? Negative 17. It's the middle number, negative 17. Okay. Okay, and so now here we got to figure out what two numbers multiply to 30 but add to make negative 17. Oh, hi. Do we, right now? Oh, okay, sorry. Okay, so do I have to, like, agree or disagree, or right now? Can I get it back to you? How do I do that? I'll bring it back to Mr. Goff, and then he can share it with you. Thank you. This is very important. Yes. Wow, number 2, Rogue One. Really interesting. All right. All right. Anyway, so yeah, we need two numbers that multiply to make 30, but add to make negative 17. So what do we got? Oh, you guys are good. Very good. Okay, but again, we're not done. That's not our answers. We've got to take those and divide them by 5. All right. And then we can simplify that. Negative 15 divided by 5 is negative 3. This does not simplify, right? So we'll end up with, what will our factors be? X minus 3. 5x minus 2. Beautiful. Very good. Exactly. That denominator kind of comes back out and becomes minus 2. So again, is that comfortable with everyone? Because I kind of would prefer to only just stick with one strategy. So, I mean, like, Carlos, is this making sense to you? You got this? Okay, good. Okay. Joshua, are you doing okay with this kind of thing? Okay. I don't want to leave anyone behind. There's another method that I've seen. It's called slide and divide. Have you guys heard of slide and divide before? It's very similar.
Kind of like box method or something.
There is a box method too. Yep. Yep. So I'll show you slide and divide because it is kind of slick. So it's called slide and divide. And the idea is you take the lead coefficient, the 5, and you're going to slide it back and multiply it with the 6. So we end up with this. Okay, so the 5 kind of like slides back to the 6. Okay. And then you factor this quadratic, which isn't too bad because you know you just need two numbers that multiply to make 30 but add to make negative 17. So again, we know what those are. It's going to be minus 15. And x minus 2. Whoops, I got ahead of myself. X minus 2. Okay, so that slide part was where we slid the 5 back, but then we also have to do divide, right? It's called slide and divide. So we're going to divide each of those numbers by 5, by the same number that we slid by. We slid the 5 back, we're going to divide by that 5. 15 divided by 5 is 3, and there's that x minus 3 we had, right? And 2 divided by 5 does not simplify, so the 5 slides back in front there of the x, 5x minus 2. So that's another way to do it too. Very similar to the magic x, or whatever you want to call it there. Okay, right? Very similar, but it does factor. Okay? Let's try another one here. Okay, let's try to factor x squared minus 9x plus 20. Alright, so now when we go to fill in that magic x there, what's our top number going to be? 20, yep. Okay, and the bottom number? Negative 9, yeah. Right, so we, what's that? 20 and multiplies by negative 9. Exactly right, yes, true. Yeah, you don't even need to use the magic x here necessarily, but it also will work, so that's why I wanted to throw it out at you too. So yeah, we just need two numbers that multiply to make 20 but add to make negative 9. Yeah, very good. You guys are good. That's very good. Okay, negative 5, negative 4. Okay. And again, if you guys are really good with like multiplication and stuff like that, it's going to be helpful. If not, you just have to use a calculator and guess and check. You know. But yes, negative 5 and negative 4. So again, the lead coefficient's 1, so we could divide these both by 1, but it's not necessary because it's just 1, right? I mean, they're going to be the same thing. So x minus 5 and x minus 4. Alright, I think we've done enough practice here, so let me see how you guys are going to do. So I'm going to give you 2 to try. So I'm going to have you try this one here. I want you to factor x squared plus 3x minus 12. And I also want you to factor another one here. Let me give you 5x squared plus 16x plus 3. Okay, so go ahead and just try those two, and then we'll be done. All right, we'll go over it, and then we'll be done. All right, so let's get someone here to help us out. All right, so Greg, were you able to come up with something for number 1 there? You weren't able to get number, not that one? Okay, you got number 2 though for us? All right, let's do number 2 then, okay? You got x plus 4 and x plus 15? Sorry, x plus 1 and x plus 15. All right, so let's take a look here. So 5 times 3, we want to multiply to 15 and add to 16. So yeah, 1 and 15 are our numbers. But don't forget, we have to divide those by that lead coefficient, the 5 there. So divide by 5, divide by 5. 15 divided by 5 is 3, so that simplifies, but 1 and 5 do not. And so then the real factors are going to be x plus 3 and then 5x plus 1. Yeah. Okay. And then let's go to, let's see, for number 1 here, let's go to Katie. You got that for us, Katie?
I couldn't figure out.
Ooh, let's see. All right, well. All right, so 1 times negative 12, negative 12. We want to multiply to make negative 12, but add to make 3. Multiply to make negative 12, add to make 3. So this is not possible. Okay, so it's not possible. No solution. Which is a possibility sometimes. Now, how are you guys able to convince yourself it's not possible? You just like looked at all the options. You're like, this is impossible. Okay, so. Right, so one option we can use is our graphing calculators to help us too. Okay, so for example here, if I graph x squared plus 3x minus 12, all right, and we look at this, well, you can see that it does cross the x-axis. So there are some solutions, but let's find them, right? So, right, if they're really like strange decimals, so let me just find this. Oh wait a minute, not intersect. I need 0. That's what I want. Sorry. Okay, so I'll go to the left of the 0. I'll go to the right of the 0, and have it guess. And if you look here, that decimal is like crazy, which means there's probably going to be a square root in it. So this could be like solved using the quadratic formula. We're not going to worry about the quadratic formula right now. Okay, it does not factor, so we don't need to worry about it. So there's no solution, or it does not factor. So that is a possibility, right? Not every quadratic that we run across is factorable, okay? So keep that in mind. If the directions, especially the directions say, factor if possible, right? If it throws in that little possibility of it not factoring, then you want to be on your toes about that, okay? If it doesn't say that, well, then still could not factor, I guess. But yeah, hopefully the directions will be you know, a little more kind to you than that. I'll try to be a little more kind to you than that, hopefully. But we'll see. I don't know. I want to make sure.